In section 9.4, we're going to talk about some relationships that can happen between x and y. And we're going to talk about direct, joint, and inverse variations. So we're going to start with an example here. The circumference of a circle varies directly to the radius, as in c equals kr. As the radius changes, the circumference changes, and there's this value k that we're going to multiply by that stays constant. We're used to looking at it like this. This 2 pi r is our k. No matter what radius we're using, we always multiply by 2 pi. And then this number changes, multiplied by a constant, makes this number change. So this is a direct variation. So y varies directly as x if there is some non-zero constant k such that this happens. I can write a multiplication problem of x times some constant k, and that will give me y, and that'll give me the relationship. So jointly implies y equals kxz or more. Another type of variation is joint variation. It occurs when one quantity varies directly as the product of two or more other quantities. So it's a direct variation with a twist. Okay, so y is going to vary jointly as x and z, there's my 2, if there's some number k that's still a constant, such that this multiplication problem is true. So for example, for a set distance, rate varies inversely to time, as in r equals k over t, or more specifically, r equals d over t. So inverse variation, as x increases or as y increases or as x increases, y decreases. All inverse variations are in the form of xy equals k, or easier to think about them, I think, y equals k divided by x. So here is your formula before. Y varies inversely as x. So y equals this constant divided by x. So again, as y goes up, x is going to go down. Or as y goes down, x will increase. So kind of like a teeter-totter. As one goes up, the other goes down. So what is going on in this situation? Okay, fuel and money in your pocket. Well, obviously, as you have to put fuel in, what happens to your wallet? Money goes out. And so this is an inverse variation. As your fuel tank gets full, your wallet is going to get empty. So, steps for solving a variation problem. So first, write the general equation. So equation with only variables in k. So is it a direct variation where you have y equals kx? Is it some sort of joint variation where y equals k times x z, or is it some sort of inverse variation where y equals k over x? So figure out which equation you're going to use. Substitute the given and solve for k. So they're going to give you usually one set of values for x and y and how they relate. Use those to find k. Then go back and rewrite the general equation using the k that you have and any additional information and solve for what's missing. So for example, y varies directly to x. So I'm dealing with this situation. So when y equals negative 15, x is 5. So this is what I use to find k. This gives me my relationship. So step 1, I'm going to say negative 15 is equal to k times 5. Divide both sides by 5. K is negative 3. So then step 2, it says find y. So this is the second situation, so I want to know y when this is my constant now, negative 3, and x is that value. And that makes y negative 9. So you're always going to have those two sets of value information. So if y varies directly as x, so I'm working with y equals kx as my pattern. My first set of given, how do x and y relate? Right here, so I can solve for k. So I've got 12 is equal to k times negative 3. Divide both sides by negative 3, and k is negative 4. Then you take that value and we use it with these numbers and say, well, here's my relationship now. So I know 7, so y is negative 4 times 7, and that means that y is negative 28. Joint variation example. Suppose that y varies jointly as x and z. So here's my generic. Now remember, in multiplication I can do these in any order, but I want to think about this k as being a separate value. So find y. So they've reworded this question. So this is actually my part 2. I need that set of values where I know all 2 or 3 so I can find k. So this is step 1. If y is 12, x is 3, z is 8. So step 1 is when we find k, so I have 12 is equal to k times 3 times 8. So 12 is equal to k times 24. Divide both sides by 24, and I have 1/2 is equal to k. Now I'm going to use that value and say, well, what is y when k is 1/2, x is 10, and z is 5? 1/2 of 10 is 5, and that means that y is 25 when it varies jointly as x and z. So suppose that y varies jointly as x and z in this situation. Find y when x equals 3 and z equals 2 if, here's where I start, y equals 11 when x equals 5 and z equals 22. So again, I'm varying jointly, so this is my starting point. So I'm going to go ahead and use my given. Y is 11 when I don't know k, 5 times 22. So that means 11 is equal to k times 110. Divide both sides by 110, and I end up with 1/10 is equal to k. I'm going to take that value and now find what's missing. Find y when k is 1/10, that's my constant, times 3 times 2. I don't have any great canceling here, but 2 and 10 will cancel, leaving 5, and so y will be 3/5. Inverse. A varies inversely as B. So we're talking about the pattern usually is x, y equals k. So let's say that AB equals k. Here's my set of values. So step 1 is to find k always. So -6 times 2 equals k. So -12 is k. We take that value and say find A when B is this. So I don't know A. I know B is -7, and it has to equal K, which is -12. Divide both sides by -7, and A is 12 over 7. And you can go ahead and leave it just like that. Now, whether you use this version of inverse or this version of the inverse really depends on what you're given and where you're going when you solve. But they really mean the same thing. The way we move from xy equals k to y equals k over x is a matter of solving for y. So A varies inversely as B. So we'll start with that general pattern. Here's my given. So step 1, I need to find k. K is equal to 2 times 8. So k is 16. I use that information to find A. So A times 6 is equal to 16. Go ahead and divide both sides by 6. And A is equal to 16 over 6, which is the same as 8 over 3. And that is the end of the 9-4 lesson.